Today we're going to be talking about radical operations and how to multiply, add, and subtract numbers that are in radicals. So first we're going to talk about the product rule. So remember that the product means that we're multiplying. So we're going to talk about multiplying first. So the product rule for radicals says that if the index of two radicals is the same, you can multiply the radicands together. So let's remember what those words mean really fast. Oops, that's not how you spell radicand. Okay, so the index, remember, is the little number that sits on top of a radical. So for example, if I have a radical with a little 3 here, that 3 is the index. And then the radicand is just the number that is underneath the radical sign. Okay, a couple things to be cautious of or to remember is that the index must be the same. Okay, so you can't combine radicals that have an index of 3 and an index of 2. The index must be the same. And the other thing to remember is that if there are numbers in front of the radical, you multiply those together too. Okay, so let's work through some examples so you can see what it looks like to dive into this product rule. So in this example A, I have the square root of 7 times the square root of 5. And those indices, or the index of both of those, are the same. Remember that when we don't see a little number on the radical, it means that the index is 2. So we can multiply these together. And the way we do that is we multiply the two numbers, the two radicands together, which is going to be equal to the square root of 35. Okay, let's look at B. So B, we have 5 square root of 2 times the square root of 8. Again, the two indices, which is the plural of index, are the same. I have the square root, two square roots. So I can multiply the radicands together. Okay. And I have this 5 out front. And the 5 is what I'm talking about with this second caution up here. There's a number in front of the radical. So I'm going to multiply the 5 by the number that's in front of the square root of 8. And that number is actually a 1. Right? So then we can simplify this to 5 square roots of 16. Okay, let's jump a little bit. We are going to jump to E really fast. This is the square root of 8 squared. Okay, so this one, if I were to rewrite the squared, I would have the square root of 8 times the square root of 8. And here I have two radicals that have the same index, so I can multiply the insides together to get the square root of 64, which is also equal to 8. Now, there's actually a shorter way to do this. If we come back to the very beginning, we do it in a different color so it's not confusing. We can come back to the very beginning and we have the square root of 8 squared. Well, the squared exponent and the square root are going to cancel each other out, so we're just left with 8. So whenever you see a square root squared, you can think about canceling them out. Basically, the square root undoes the square, and the square undoes the square root. So they undo each other, and we're just left with whatever was in the radical. Okay, and that is our few examples of how to do the product rule for radicals. So now let's talk about adding and subtracting. So the big question is, can you add and subtract radicals in the same way that you multiply and divide them? So like if I have the square root of a times the square root of a equals the square root of a times b, that's what we just barely did, the product rule. Is it also true that the square root of a plus the square root of b would equal the square root of a plus b? And the big answer to this is no. Okay, adding radicals is a little bit more complex than just adding the radicands together. So here's our stipulation. You can add radicals together if they are like radicals. So we're going to talk about what that means. okay? We're actually going to jump down here where I have a little definition for like radicals, okay? So a like radical means that both the index, whoops, I combined both in the, so both the index and radicand are the same. Okay, so if we have two radicals where the index and the radicand are the same, then they're considered like radicals, and we can add them together. So let's just jump down and do these examples right underneath here at the bottom of the page really fast, and then we'll go talk about some common mistakes that happen with adding and subtracting radicals. So with A and B, we're just going to decide if these two radicals are like radicals. And in A, the answer is no, because the radicand, or the number inside the radical, is different. So the radicands are different. In B, these two are like radicals. Yes, because we look at the square root of 5 part. Get my highlighter out. The square root of 5. And that square root of 5 has the same index because they're both square roots, and the same radicand because they're both 5s. So the 4 and the negative 3, the 4 square roots of 5 and the negative 3 square roots of 5 would be like radicals. Okay, let's talk about a few common mistakes that people often make when they're adding radicals. So basically what happens when you find two radicals that are like radicals, you just add the numbers that are in front of them. So if we were going to add 4 square roots of 5 plus 3 square roots of 5, then we would have 8 square roots of 5. You can kind of think about it like an x, like that square root of 5 like an x. If you have 4x plus 3x, you're going to get 8x. Oh man, not 8. How embarrassing. 4 plus 3 is 7. You're going to get 7x, or 7 square roots of 5. Okay? So the key here is that you're only adding the numbers that are in front of the radical together. So here's a couple common mistakes. I am going to do the mistakes in red so it's clear, hopefully, that they are incorrect. So if I have the square root of 5 plus the square root of 3, lots of times people will want to add the radicands together and get the square root of 8. That is a big no-no, okay? If we have, so over here I'll do the, let's see, let me get up a black marker. So over here I'll do like the correct version of this. If I have the square root of 5 plus the square root of 3, I can't simplify it anymore. So that's it. I can't add those together. So I wouldn't do anything there. Okay. Another common mistake we see a lot is, say I have the square root of 3 plus 2 square roots of 3. So in this case, we have like radicals. We have 2 square roots of 3, and we're adding them together. Lots of times people will get 2 square roots of 3 for this answer. This is actually incorrect. The correct answer is that the square root of 3 plus 2 square roots of 3 is equal to 3 square roots of 3. So we have to remember that in front of this first square root of 3, there's actually a 1, right? It's kind of like how whenever I see an x, I always could think about having a 1x in front of it. So you have to remember that there is a number in front of that radical. Another common mistake we see is very similar to the last one. I'm going to give an example of subtraction though. Say I'm doing 4 square roots of 3 minus the square root of 3. I do have like radicals, so I can subtract. So I would subtract the numbers in front of the radicals. People will often put 4 square roots of 3 on this one for the same problem, for the same reason as the last time, is they forget that there is a 1 in front of that square root of 3. This should actually be 3 square roots of 3, because you would do 4 minus 1 to give you 3 square roots of 3. Okay, now that we've seen a few common mistakes that people make when adding and subtracting radicals, let's come up with some steps for adding and subtracting radicals and do just a couple examples. So steps for adding and subtracting, the first step is to determine if the radicals are like radicals. Okay, that should be the easy part. The second step is to add or subtract the numbers that are in front of the radicals. Okay, let's take a look at what that would look like. So looking at example number A, or letter A, I have 5 square roots of 3x minus 7 square roots of 3x. First of all, I recognize that I have like radicals because I have square roots, and I have 3x in both of the square roots. So I'm just going to subtract the numbers out front. So 5 minus 7 is going to be negative 2, and then I keep whatever's in the radical exactly the same. That's what it's going to be. Okay. Let's skip forward a little bit. Let's skip over to C. So here I have 10 square roots of 6 plus 3 square roots of 2 minus 8 square roots of 6. So here I have these square roots of 6 that are like radicals, and then I have that square root of 2 that is not a like radical. So I'm not going to be able to do anything with the 3 square roots of 2, so I'm just going to leave that alone. But I can combine the 10 square roots of 6 and the negative 8 square roots of 6. So since they're like radicals, I subtract the first number. So 10 minus 8 is 2 square roots of 6. So that is how that set of radicals is going to simplify. Okay. Let's jump down really fast and talk about multiplying radical expressions when one factor is a single term. So we already kind of talked about how to multiply radicals. This is just going to get a little bit more interesting, where I'm going to have, like in these examples down here, I'm going to have a set of parentheses that have some radicals in them, and then I just have a number out front. Okay. So the first step in this situation is to distribute the number out front. Okay, once I've distributed the number out front, then I'm just going to multiply like I did before. So that might just be multiplying integers, or doing the product rule for radicals. Okay, so let's just take a quick look at a couple of examples. So if I come to this first one, I have 5 times 4 minus the square root of 2. I'm going to distribute this 5 in, so I have 5 times 4 minus 5 times the square root of 2. So I have to multiply the 5 that was on the outside into everything that was on the inside. And then I can just simplify some things. So 5 times 4 is 20. I can't really do anything to simplify this second piece, so it's just going to be 5 square roots of 2. Okay. Let's look at letter B. This one's a little interesting because I've got a mixture of integers and radicals. So again, my first step is just to distribute this negative 3 in. So I have negative 3 times 4 square roots of 5 plus negative 3 times the square root of 12. So with this first term, I can combine the 3 and the 4, multiply them together to get negative 12. I can't do anything with that radical, so it just stays the same. Since I'm adding the negative 3 square roots of 12, I'm going to change that into minus 3 square roots of 12. And that's what that final answer will look like. Okay, let's work through one more complicated example. Let's work through E. Okay, I'm going to distribute 2 square roots of 3 into my parentheses. So I have 2 square roots of 3 times 4 square roots of 3 minus 2 times the square root of 6. Okay, so remember when I am multiplying radicals like this in this first term, I'm going to multiply the numbers out front together, and then I'm going to multiply the numbers that are inside of the radical together. So I get 8 square roots of 9, and the 2 square roots of 6 just stays the same. And this one's nice, because I know what the square root of 9 is. The square root of 9 is 3. So I can actually simplify this first term even more to 24 minus 2 square roots of 6. That's what that final answer will be. So we went from this super nasty thing that we started with to a really nice and simple one at the very end. So that's kind of the benefit of doing these operations of adding, subtracting, and multiplying radicals, is you get something that's sometimes a lot easier to work with.